Hey, it's Mr. Lum again, and we're going to continue on with some Science 9. Last time we talked about some of the history of the chemistry and Niels Bohr and Rutherford and Chadwick and a few of those major guys there. One person that I also want to talk about is this guy right here, and his name was Dmitry Mendeleev, and he created or discovered the periodic table, and he took the properties and organized the elements based on their properties. And Dmitry Mendeleev was a very, very smart person, and we're going to discuss what made him so smart. So first off, here's a picture of Dmitry, and here is one of the very first examples of the periodic table that he came up with. And what made him so smart wasn't the fact that he simply just took the elements that we knew about and organized them. That was actually done by many other individuals. But what made him so smart was that he was able to predict the discovery of elements that haven't been discovered yet. And so he was so smart because he left blanks in the periodic table. So we're going to take a look at this. So for example, let's take a look at one right here. Here was aluminum right there. Okay, there's oops, I shouldn't do that one right there. I should go more like, here's aluminum right there. Okay, but then what made Dmitry Mendeleev so intelligent is that he said, I don't know what goes right here, right? But I do know that it's going to have like a mass of 68. I don't know what goes right here, but I do know that it's going to have a mass of 72. Okay, and he left all these blanks in the periodic table, and he would also describe it. He would describe its mass, he would describe its density, he would describe what it looked like, he would describe its melting point and boiling point. He knew so many different things about that element, and that element hasn't even been discovered yet. And he would leave a blank in the periodic table here, here, and he left all these other blanks all throughout the periodic table. And he would know everything about it. And what made him a very intelligent person is that sometimes people would contact him and say like, hey, I discovered an element, and I think it's the element that goes right here in your periodic table. And Mendeleev would say like, oh, tell me about it. And the person would say, this is the melting point, this is what the boiling point is, this is how dense it is, and this is what it looks like. And Mendeleev would say, if it was way off from what he predicted, he would say, no, that is not the element that goes there. That doesn't belong there. And he wouldn't even look at it. He wouldn't even and he would say like, it doesn't fit the pattern which the periodic table is organized in. And other scientists would get upset with Mendeleev, saying like, you haven't even looked at the element I discovered. And he would say, I don't need to look at it. It doesn't fit the trend that is the periodic table. The reason why it's called the periodic table is because these properties would reoccur periodically. And he would say, it happens, they reoccur periodically. And if it doesn't fit what I think the melting point, the boiling point, what the color should be, and the density of it, then you didn't discover it. And he wouldn't even have to look at the element. And what crazy thing is that Mendeleev was right. And a lot of scientists were upset with him at that time, but he turned out to always be right. So I do want you to watch a small video. It's like a 5-minute video on Mendeleev. So put my video on pause right now, and I want you to go and watch the other video, and then you can unpause this, and we can move on from with our talk. Okay. So I hope you watched the Mendeleev video, which is like that TED Talk kind of video. It's quite interesting. But yeah, anyways, we're going to be moving on and talking about some other things regarding the periodic table. And I want us to get more familiar. I want us to get more familiar with that periodic table. So first off, the periodic table is organized in a lot of different ways. And we're going to talk about all the different ways that it's organized. So first off, there are two major type of elements, metals and nonmetals. And metals are typically shiny, typically malleable. And if you research what malleable means like moldable. And if you think of something like copper, you're probably thinking copper is not really moldable. I can't really mold it into anything. And that's because we lack the strength. But what malleable kind of means is that, like, if you hit it, it will bend and deform, but it won't necessarily break. Okay. Brittle means that it will, if you hit it, it will crack or shatter, right? And brittle in chemistry doesn't necessarily mean weak. Like, for example, a diamond is considered brittle. A diamond is considered brittle because if enough pressure is put onto a diamond will crack. If a bunch of pressure is put onto, say, gold, the gold will squish. So diamonds are considered brittle, and metals are typically malleable. So the other one is that metals are what are called good conductors. Heat and electricity can go through it quite easily. They're typically solid at room temperature. There are a few exceptions here and there, like mercury and gallium is at a very warm temperature will turn into liquid. And nonmetals, some of them are shiny, but sometimes often they are not shiny. They are typically not really good at conducting heat or electricity. They are brittle, and we talked about that. Brittle doesn't mean weak. Brittle means that if it's struck hard enough or enough pressure is put onto it, it will shatter. And they can be gases at room temperature. And many of them are not, but they can be gases at room temperature. Okay, now hopefully you have a copy of the periodic table, and I wanted to just emphasize this one little thing right here. The nonmetals are on this side of the periodic table, and the metals are on this side of the periodic table. So here is the line that sometimes we refer to as the staircase because it looks like a staircase. Everything on this side of the line is a non-metal. Everything on this side of the line is a metal. So there's way more metals than non-metals. Non-metals are up here, okay? Now, you're probably wondering, what about this hydrogen here? It's listed in 2 places, okay? Hydrogen is a non-metal. That's just that. Hydrogen is a non-metal. Now, hydrogen is on this side right here because there are a few weird properties with hydrogen which can make it act kind of metallish in some ways. But definition speaking, we are putting hydrogen as a non-metal. But there are some weird properties with hydrogen, and it can kind of have occasionally some metal-like properties to it. Okay? So I want us to get a little bit more familiar with the periodic table, and what I would like you to do is on a scrap piece of paper, please take out a scrap piece of paper, And what we're going to do with that scrap piece of paper is you are going to decode sentences and make sentences in here. So let me give you an example first. So I made a very small sentence, and the sentence that I made is iodine, tungsten, iodine, nitrogen, acetine, lithium, iron. Okay, so if you find all of these elements on the periodic table and look at their symbols, it will spell something out. So what does mine spell? Well, iodine is I, tungsten is W, iodine, I again, nitrogen, N, so I win. Acetine is AT, I win at, and then lithium and iron spells out life, I win at life, okay? And so occasionally what some people will do on their grad write-up in the yearbook is they will write a coded message in chemistry and write that as their yearbook quote, and it spells out something. It's like a secret coded message. But so what you're going to do is you're going to make one of these secret coded messages on your scrap piece of paper and pass it to someone and let them see if they can decode it. And what this whole process is just getting us more familiar with the periodic table and finding different letters and stuff like that, just becoming a lot more familiar with the periodic table. So you have a little bit of actually on your guided notes, you have a little bit of space to write your coded message. I wrote another coded message right here, and that you can try to decode. You can put the video on pause if you want to give some of the students some time to see if they can decode the message. Maybe put it on pause for like 2 minutes, and then yeah, and see if they can decipher my coded message. So hopefully now you've decoded my message. Yttrium, oxygen, uranium, barium, carbon, potassium, uranium, phosphorus spells out you back up. Okay, so I want you to practice writing some coded messages and then share them with the class if you feel comfortable, and share them with other people around you to feel comfortable as well.